This tutorial will show two different uses of the insertion point command. Insertion points are used to position frame objects that are offset from center lines. Our first example is a simple 5-story, 1-bay planar frame where the columns increase in size as we go down the building. Starting with a W14 followed by a W16, and then a W18, W21, and W24. Although these are not necessarily realistic column sizes, they help to illustrate the use of the insertion point command. If we switch from a wireframe to an extruded view, we can see that the default orientation of the members is such that the centroid of the frame objects line up with the wireframe outline. However, if we cut a section through a column, we can show that there are many options for locating the frame objects relative to the wireframe. With our wide flange section displayed, if we go to the Assign, Frame, Insertion Point command, we can see that we have many options for the cardinal point location. The cardinal point is the location on the frame object cross-section through which the local longitudinal axis of the element passes. Again, the default is the centroid, but the cardinal point may also be the top right, top center, or top left. And if we scroll up, we can see that the other options are bottom left, bottom center, bottom right, and middle left, center, and right, as well as the shear center. Now let's see how moving the cardinal point affects the model. We start by selecting the entire frame and going to the Edit Replicate command, where we will replicate a second frame. Next, we select all of the columns on the right side of the duplicated frame and go to the Assign, Frame, Insertion Point command. Here, we will change the cardinal point from the default setting of centroid to the top center option. If we zoom in, we can see how the columns are now flush to the outside face. We repeat the process on the left side columns. This time setting the cardinal point to be bottom center. Windowing in again, we see that the outside face is flush and that the entire offset between the column sizes is shifted to the inside face of the column. The last thing that we will do before running an analysis is to add a lateral load of 10 kips to the top of each frame. We are now ready to run the analysis. First, we will display the moments due to the lateral analysis case. For the columns oriented along the centroid, the base moment is approximately 767 kip inches, while it is approximately 828 kip inches for the columns flush with the outside faces of the frame. There is also a significant difference in the lateral displacement between the two frames. Now on to the next example. In the second example, we will show how cardinal points affect beam behavior, and we will use a simply supported concrete beam with concrete slabs to each side. When first drawn, the default settings are such that the slab and beam centroid all exist in the same plane. If we look at the model in an extruded view, we see that indeed the slab is located at the center line of the beam. However, in reality, we want the slab to be at the top of the beam so that it behaves as a flange. We will create a copy of the first beam so that we may revise it to have the slab at the beam top. We start by selecting all the objects and going to the replicate command. We select the second beam and go to the Assign Frame Insertion Point command. Here, we select a cardinal point of top center. Note that the beam has moved down so that its longitudinal axis is at the top. The 3D view shows that the slab is now at the top of the beam. We will now run a static analysis. We will use a dead load case with self-weight. It is readily obvious from the deformed shape that the first model is much more flexible. The center displacement of 0.08 inches is more than twice that of the model on the right. This is due to the flange action of the slab in the right model. The moment is also much larger in the model on the left. A check of the shell forces shows that the shell elements in the left model do not carry any force due to the fact that the slab is located at the beam centroid, where there is no bending strain. In conclusion, the use of the cardinal point option of the insertion command allows for the accurate placement of frame objects, which in turn can have a significant effect on forces and displacements in the model. This concludes this tutorial.